All right, so I know the original title of the talk that you got in the meetup announcement was a little bit different, but this is the actual title of the talk. There is a reason for the change. This is also the title I've given it under a number of times. But anyway, we're going to talk about building a better OpenStruct. I'm just curious, how many of you have worked with OpenStruct in the past in any capacity? Okay, so a good number of you, probably looks like the majority, and that's great. But I still think that there are a few things about OpenStruct that probably you don't know. So let's talk about OpenStruct. Again, just a quick review of what it is, why we might want to use it, and then we'll dive in and really see how it works. So I like to think of OpenStruct as Ruby's JavaScript object. The reason being that you can get and set properties using either dot notation or bracket notation, very similar to how it works in JavaScript. So you require OStruct from the standard library. You can create it with a hash. In this case, we're passing in a hash with a key of the symbol foo and the value bar. Once you've already created it, so again, you can create it just kind of bare without any hash, or you can pass in a hash, up to you. Once it's created, you can still add properties using dot notation like .baz equals 4, or using bracket notation. In this case, we're using the symbol something and setting it to whatever. And you can use symbols or strings. They work exactly the same. You can use them interchangeably. Once things are in there, in order to retrieve it, so you can use dot notation, right? These are just values that we put in before. On the bottom, you'll note that if we try to access a property that's not defined, so in this case, quux, we haven't defined it, so it'll just return nil, right? It's not going to be like any other Ruby object where if you try to use a method that's not there, generally you'll get some sort of error. In the case of OpenStruct, it's just going to return nil, right? Again, very similar to JavaScript. You try to access a property that's not there, you get undefined, and usually you'll end up seeing undefined is not a function somewhere. Again, you can also use bracket notation to get things out. Symbols, strings, all works the same. Very nice. Why do we care? So there was a talk at Rails Israel a few years back by Eric Michaels-Ober. He actually now goes by Eric Berlin, one of the few people whose name went from 2 words to 1 word after they got married. So I found that interesting. But if you Google the talk, you'll find it under Eric Michaels-Ober, so I just left it that way on the slide. So he listed 3 common use cases for OpenStruct. I'm stealing the list from him. I'm using my own examples, but I need to give credit where credit is due. So this is the most important use case for the purposes of our talk. We're going to talk about consuming an API. What does this look like? How does OpenStruct help us out? So imagine that you make a call to an API. Usually you get back some kind of JSON object, right? It's generally either that or you get an array of objects. But the principle would be the same there. You just map over it. So you get your hash out, and then you just pass the hash into an OpenStruct, and now you can again use dot notation or bracket notation to access the properties. What you can do that's a little bit more complex, a little bit more interesting, and we'll dive a little bit more into this advanced strategy. But basically, you subclass OpenStruct, and then again you get your response back. But instead of passing it into just a plain OpenStruct, you actually create a new instance. Here it's called API call. That's not very descriptive. Usually you call it post, author, bill, invoice, whatever is the appropriate domain object for your system. Whatever is represented by this API call, you can actually give it a name. And so you have an object with properties that you're just basically pulling off of an API. Again, you make your call and you pass the response into a new object of your class. No method definitions required. All right. So again, just to kind of sum this up, we get an API response. It has various keys and values. If you just leave it as the bare hash, you have to use bracket notation. You also have to use strings. If you use OpenStruct, you can use dot notation, which doesn't seem like such a big deal. But it is kind of nice to be able to interact with your objects as objects rather than thinking of them as data structures. Now, if you use the more advanced idea that we mentioned on the last slide, where you subclass OpenStruct, you can start to do cool things like this. So here we have a user, which again inherits from OpenStruct, and it defines behaviors that depend on the properties. So in this case, we're going to make our API call. We get back a user object with a first name and a last name. We pass that into our user object, and now we can call .name on it, and it will calculate the name from first name and last name, right? It's a pretty trivial example, but the idea being that from the outside, you don't know what's an attribute that's just stored in data and what's a computed property. So it's a real nice object-oriented way of working with your API object. You can basically decorate this hash with behavior now because you're wrapping it in some kind of object. Okay, so that's use case number 1. Number two is a configuration object. Let's say you write a Ruby gem and you want to have a configuration DSL, something like this, right? So you call configure. This is pretty similar to how Rails does it, our spec does it. Not exactly the same, but it looks pretty familiar to the average Rubyist. So you have a configure block, it takes a configuration argument, and then you can just start setting all kinds of settings on the configuration object in that block. In order to implement this, all you need to do is these few lines of code. The configuration is just going to hold an OpenStruct, and when you call configure, it'll just yield that configuration, and you can set arbitrary keys and values. There is a danger here, because if somebody here, instead of writing setting with 2 T's, they put 3, there's going to be no error. Nothing's going to validate that the settings that they're choosing actually match the settings that are available. So it is a little bit dangerous to do this. I don't necessarily recommend it, but you see it out there in the wild. It happens, and it's just good to know about. All right, the last thing is a little bit complex. It's OK if you don't get all the details. We're just trying to kind of run through the common use cases real quickly. This is just, again, just a good technique to know about. So let's say you have an order class. It takes a payment gateway in products, right? We're injecting the payment gateway because we want to be good object-oriented programmers, dependency injection. And then when you call pay, it's going to sum up the total cost of the product, and it'll charge your payment gateway. Now, if in your test suite you pass in a real payment gateway, right, this is going to be expensive to test. And I don't mean that it's going to be a lot of CPU cycles to test. I mean, if you put in someone's credit card, it's going to charge someone's credit card every time you run your test, right? They're going to look at their bill next month and be a little bit confused as to what's going on. So obviously, you're not going to actually use a normal payment gateway. You want something that quacks like a payment gateway, right? Something that has the same interface, but is not going to actually talk to any billing companies. So it turns out that a really easy way to do this, right, no extra libraries or anything required, is just to use an OpenStruct. So any key and value that you set in an OpenStruct becomes a method and its response. So in this case, we create an OpenStruct where the charge method simply returns the symbol paid. And it satisfies whatever our payment gateway was doing. So you can just pass it into your order and assert that some result comes out. You can also use it as a mock. This is less common. But let's say you wanted to assert that something was set on the payment gateway, you could do that too. But again, it's just a very lightweight test double. It works really well. And I've definitely done this a whole bunch of times. All right, so we got our 3 cases. Again, consume an API, configuration object, and a test double. Now, how does it work? What's going on under the hood? Well, OpenStruct, well, actually, before I get to that, I just want to warn you, the code that you look here, don't hold me to it byte for byte. I've absolutely made lots of changes and edited things, because the goal here is not to look at the exact code and understand every edge case that we're trying to deal with, right? The goal is to understand how things work. And so I've pulled out a whole bunch of random bits, things that aren't going to help us understand how it works. There's code here that if you tried to run it, it would fail in some way. So don't hold me to it. But in general, it will be close enough that you can really understand how things work, hopefully pretty easily. All right, so under the hood, what's going on is OpenStruct is defining singleton methods on the object's singleton class, right? It's defining all these getters and setters on a singleton class. And that's, I realize, a thing that we've spoken about it in the last couple of meetups, a lot of these metaprogramming concepts. But just a quick review in case it's not familiar to somebody, totally fine. So in Ruby, we have any random object. We are able to define methods on that object, and they are just there for that one object in our system. So in this case, we defined a bar method on our foo object, and we can call it foo.bar. It works just fine. And if we ask foo, what are your singleton methods? What are the things that are defined only for you? We'll get this array of just bar, because that's the only one that we defined. Now, the reason we talk about a singleton class is because technically they're not defined inside of the object. Objects don't have methods. Classes have methods. So every object in Ruby secretly has a class that exists just for that object. It's inserted into that object's inheritance hierarchy. And that's where those methods actually live. But if that's too much to remember, totally fine. The main thing to remember is we can, in Ruby, define methods just for one object. All right, so with that in mind, let's take a look at what happens when you create a new OpenStruct and you pass in, again, foo and bar, right? Simple key value pair. So we hit initialize, right? As with any Ruby class. Again, that hash is optional. The first thing we're going to do is create a table instance variable. We're going to set that to a hash. And that table is going to hold all the information that we're putting into our OpenStruct. That's where all of our data is going to live. If we don't have a hash that we passed in, then we're done. But if we did choose to pass in a hash, as we did in this case, right, again, key foo value bar, so it'll take the hash, and for each key value pair, it will simply set the symbolized version of the key and set that key value pair inside of our table. And then it's going to call something called new OStruct member. We're going to talk about that in literally a minute. But before we do that, I just want to jump to one other situation, and then which also uses new OStruct member, and then we'll kind of understand those two together. So let's say once the OpenStruct has been created, you're going to set another key value. You're going to set baz equal to 4. Well, in Ruby, this is just syntactic sugar for sending the baz equals method with an argument of 4. So we're going to hit method missing because there is no baz equals method. And what it's going to do is call ID to name, so that converts the key of baz, sorry, the symbol of baz equals into a string. We try to say, okay, is the last character an equal sign? If so, then it's a setter. So chop off that equal sign, and then we're going to again call new OStruct member with the key of baz, and then we're going to set the key value pair in the table. So arg0 here is right the first argument to the method. Again, we sent the baz equals method with an argument of 4. So we're going to set baz equal to 4 inside of our table. The other branch will be hit if we just call a getter, so OpenStruct.baz, and we don't have a baz method defined, so we're just going to pull the value out of the table. Okay, so it's all just putting things in and out of the table, right? Very, very straightforward. All right, now what is this new OStruct member? Let's talk about that. So we convert the name to a symbol, and we say, do we already have a method with this name, right? So again, let's say it's baz that we're trying to make as our new OStruct member. So do we have a baz method? Because if so, I don't want to mess with this. I don't want to define a new baz method that's going to overwrite whatever was there. I'm sure there's a good reason why it's there before, and then we're done. But if it doesn't respond to the baz method, then we're going to start defining methods. So these two lines of code are kind of where the magic happens. Where we're defining singleton methods, we're going to define a getter first, followed by a setter. So in this case, it'll be the baz method, which pulls baz out of the table. And we're going to have the baz equals method, which puts whatever is the first argument into the table. Okay, pretty straightforward. It's kind of like add a reader and add a writer, but with two major differences. One is it's not talking to instance variables like a normal add a reader, add a writer. It's using the internal table. And the other difference is it's a singleton method, right? It's not being defined on any class. It's being defined on the singleton class of this one individual OpenStruct object. All of which means that no two OpenStructs share a set of methods. They have to actually be defined every single time. Every time you create a new OpenStruct, we're defining, doesn't matter if we've defined a million OpenStructs with the same exact set of methods, we're going to have to start again, define these methods every time. Okay. So that's all how OpenStruct works. Let's talk about the problem. The problem is OpenStruct is slow. Now, how slow is it? I tried to give it a rating in snails, but I don't know, I just ran out of snails, and I still wanted to keep going. So instead, I'm going to give you a more quantitative sense. It's depending on the benchmark, depending on the use case, somewhere between 10 and 40 times slower than a normal explicitly defined class, and that's actually pretty terrible. It's a good reason not to use it in your system if you can avoid it in many situations. But without just complaining, like let's actually think about how we can do something about it, and it starts with understanding why it's slow. Okay, so the truth is there are actually, I would describe it as 2.5 reasons, and you'll see what I mean in just a sec. So the first thing is defining methods is slow. This is for sure the biggest problem with OpenStruct. Defining methods takes a lot of time in Ruby. That just seems to be how it is. Second thing is that method missing is pretty slow because we have to basically find out that the method is not there, and then basically we're doing 2 rounds of going through the object inheritance hierarchy just to figure out how to run this. So method missing is pretty slow. And then this is the half reason, because it used to be true, but it's not true anymore. So you'll see out there a lot of blog posts, especially if they're from a few years ago, that say, oh, don't use OpenStruct because it's going to invalidate the global method cache, and that's terrible for performance. And that's true. It is terrible for performance. But since Ruby 2.1, it does not invalidate the global method cache, and so that's not going to be a problem. OK, so what is this global method cache, and how does it work, and what was OpenStruct doing to it? And why is it no longer a problem? This is actually a really interesting story. But we have to understand how method lookup in Ruby works. Okay, so let's say we have this simple object hierarchy. We have an animal class, which inherits from the usual suspects up above, and it has two subclasses, and the cat class includes a meowable module. Okay, Rails conventions, everything is a bull. So let's say we create a new cat, and we call 2s on the cat. Well, Ruby says, great, I don't know where 2s lives. Let's look around and figure it out. So we start with cat, and we just kind of run around the included modules, the ancestors, and finally we hit kernel. Okay, kernel is where 2s is defined for a cat. Great, we're going to write it down in our global method cache. Okay, the global method cache basically just stores all of these lookups. There's a limited number of how many we can store, but that's where they all live. Okay, now what happens if I reopen the cat class and define a 2s method? Well, this is no longer valid information, so I have to wipe it out. That's what you would think would happen, but what actually happens is this. We just destroy, we blast the whole global method cache every time a new method is defined. And there are performance reasons for this. It's not like a terrible decision. It would take a lot of time to basically hunt through the global method cache and find the right thing. But basically, yeah, this is what happens. So what happens when you create a new OpenStruct? Well, we just defined a foo method, and we defined a foo equals method, and so our whole global method cache is gone. And we have to redo all of those lookups. And looking up methods, again, is really, really expensive. And if you want to know why, look no further than active record. This is the inheritance tree. I did this a couple years ago. There's probably a few more lines in there. But yeah, there's a lot of places to look through in a lot of cases for these methods. And so yeah, it's really, really expensive. And having to basically wipe it out and do all these lookups again, we don't want to have to do that. And OpenStruct really was creating a lot of problems. So James Golick was a member of the New York City Ruby community. Unfortunately, he passed away a few years ago in a car accident while he was on vacation. But while he was still alive, so he found that he just did some profiling, and he found that in his particular Rails app, about 10% of the CPU time was spent just rebuilding this global method cache. And it was going to be really difficult to get rid of all the things, not just OpenStruct, there are a couple other things that also you can do in the midst of a running Ruby program that can invalidate the global method cache. And it was a real problem. And just to rewrite everything not to do those things was going to be just an absolutely daunting task. So he said, okay, well, I'm not going to do that. Let's just create a better version of the method cache. And so he created this idea of a hierarchical method cache. He originally wrote this back in the days of Ruby 1.9, took some time to go through the process. It was finally included in Ruby 2.1. And assuming you are using Ruby 2.1 and above, this is no longer an issue. Now let's talk about how that works. So you can think of it, this is not exactly how it works. There's like magical mathematical things happening, but fundamentally there is now a method cache for every individual class. And there are links between them, such that, let's say I define a new method on animal, well, I have to invalidate that method cache, and so I have to invalidate cat as well, right? Anything that inherits from the affected class is going to also propagate to all the children. However, if I define a new method on dog and I invalidate that, there's no possible reason that would affect cat, and so cat's still good, right? In other words, we only invalidate the parts of the cache that could be no longer valid. And so when you define a new OpenStruct, right, this is not going to just blast away your whole global method cache. It'll reset the method cache for your OpenStruct, but that's it. So if you want to read more about the deep implementation details, by the way, it's amazing that he's been dead for a few years and his website's still up. He clearly had some kind of plan, or someone continued it. I think that's just really cool. But yeah, you could read there. Kind of the deep technical details is actually quite interesting. But the main point is Ruby 2.1 and above, again, you can create OpenStruct without slowing down the rest of your application. It's not just going to crash your whole application's performance. However, OpenStruct itself is still slow. It still takes a lot of time to do the usual OpenStruct things. So I've spoken a lot. I haven't said hi to everybody, so hi, everybody. I'm Ariel Kaplan. You can find me online at amkaplan. That's important if you are interested in looking up later any of the code in this presentation. There are a couple of repos that I'm going to make reference to. That's where they all live. I know everyone's interested in .dev domains now since they just came out, but I got a Ninja domain when they were cool, so I'm just going to own that decision. I work at Cloudinary. As was mentioned, we are in Petah Tikva, so hence not hosting. But we help you store, manage, transform, and serve images and videos. I have some very cool stickers. And we are hiring, as is probably everybody. So anyway, I used to work at Vitals, and I don't usually put former employers in my presentations, because that's just like a thing you don't do. But I think it's important to mention here just because I'm going to mention some design decisions about our app. If you disagree with them, don't blame them on Cloudinary, blame them on Vitals. Which is actually not even called Vitals anymore, but it's fine. So back at Vitals, we use a system of microservices and external APIs communicating via JSON, parsed into Ruby hashes, and finally fed into OpenStruct. So OpenStructs were kind of the medium of communication within our system, right? They were mediating all these JSON blobs going around. And we had some performance issues, and I did some profiling, and I found out that OpenStruct was one of the major culprits in our system, and we really had to do something about it. Now, in case you're wondering, well, what did that look like, right? How do I profile, right? Probably many of you have never profiled, probably many of you have. But in case you haven't, this is all the code that you need in order to profile a Ruby program. There are a number of solutions that are out there now. I really like StackProp. It's been around for quite some time. Recently, Julia Evans came out with RB Spy, which takes a very, very different approach to profiling. But this is the one that we used, so I'll just mention it here. So you basically surround the block that you want to profile with this stackprof.run. You can choose CPU mode or wall mode if you want to measure time taken. If you think that there's some issue of lots of objects being created and creating a heavy load for your garbage collector, you can also use object mode to trace object allocations. You choose an out file, so that's just where am I going to dump the information, and that's it. And then you run your code. Once you've run that block, you'll have all that information in the out file, and you use a stackprof executable to just generate. You can generate text output. You can use GraphViz to create a really cool graph. There's a flame graph version, but I'm just going to show you the text output. So it looks something like this. It'll tell you here's where the most time is spent in your code. And you can see we had a lot of XML stuff also. That was not our not anything we could do anything about because we were dealing with it with an external SOAP API. But there's a lot of OpenStruct going on there. It looks like if you kind of go down the chart, and there was a lot more lines. It was about 20% of our app time was spent just with OpenStruct stuff, and that was pretty bad. So as an aside, congratulations, now you know how to profile. If you ever forget how to do it, you can look it up. It takes 4 lines of code in one slide. So yeah, go ahead and profile. But again, we wanted to keep OpenStruct because it gave us flexibility, but we had these performance problems. So the question became, can we build a better OpenStruct? Sadly, the answer was no. So thank you very much. I appreciate your time. No, I'm just kidding there. That would have been really funny if I ended there, though, wouldn't it? So the answer is yes, we can absolutely build a better OpenStruct. In fact, there are several ways. I'm going to tell you 4 more stories. I count the story with James Golick as the 0th story. But these are 4 more stories about making OpenStruct better or a better version of OpenStruct. OK, round 1, OpenFastStruct. What is OpenFastStruct? That was my question when I saw this in my Ruby Weekly email. OpenFastStruct, a faster OpenStruct. So I was intrigued. I knew that we were having issues with OpenStruct, and I wanted to see if this could be a solution for us. So I followed the link to GitHub, and it said that OpenFastStruct is similar to OpenStruct, but it's about 4 times faster. So I'm like, OK, drop-in replacement sounds pretty good. Let's see how it works. Let's read some code. And it's really only about 100 lines. It's actually a pretty quick read if you're interested. So what happens when you create a new OpenFastStruct? Again, similar API, right? You can pass in a hash, or you can choose not to. So we're going to hit initialize. Initialize, again, optionally takes a hash. For whatever reason, Arturo Herrero, who created this gem, decided to call it members instead of table. But it's the same thing as the table in OpenStruct. And then we call update with our args, which simply splits it into key value pairs, passes it on to a sign. And there we have just, key converts to a symbol, key value pair stuffed into our members. So pretty much the same as OpenStruct minus the new OStruct member stuff, right? We're not defining any methods yet. And then there's method missing. So this is a lot to take in. I'm going to try to break it down for you. So in Ruby, if you have a hash and you call the fetch method, now fetch takes a lot of different combinations of arguments, and they all have radically different behavior. It's a very interesting method. But in this case, if you call fetch on a hash, you pass it a single argument, in this case name, and you give it a block. What it's going to do is say, OK, is the name that we passed in, is that a key in the hash? If so, return the value, and we're done. And that'll happen if, let's say, again, we set Baz at initialization. So we call .baz, Baz exists, right? It'll just return the corresponding value for Baz, which in this case would be 4. If Baz is not in our hash, then we get to the other parts of this method missing. So basically, we have to ask, is it a setter or a getter? If it's a setter, i.e. the last character of the method name is an equal sign, well, great. All we have to do is grab everything except for that last character. That's the 0 to -2, right? Everything minus the last character. So in this case, it would be just the Baz part of Baz equals. And args.first would be 4, so we're just going to assign that into our call it members. And what's that remaining case? Well, that's if we try to access a property that's not there. So in this case, we call .foo. Foo does not exist. And here's where OpenStruct would return nil. But in this case, for some reason, it's going to assign a new instance of OpenFastStruct to the foo key and return that. So that's interesting. But the kind of the main takeaway, again, is that OpenFastStruct is not paying the upfront cost of defining methods. Basically, it's saying, we'll just rely on method missing all the time. We're never going to bother defining methods. And the truth is, if you don't access properties a lot of times, method missing is slow, but defining methods is way slower. And so this ends up actually, ironically, being a whole lot faster. I've done different benchmarks different times. It was somewhere between like 4 and 10 times that you have to hit method missing before it becomes worth it to define the method. So in most cases, like how many times are you going to actually use these properties? Probably not that many, unless it's a configuration object. If it's a configuration object, this is a terrible idea, because then you're hitting method missing all the time. Unfortunately, OpenFastStruct did not work in our app because of that behavioral change. So let's just kind of look at this from the outside in. Okay, so there was that asterisk on this slide. It says it's not exactly like an OpenStruct. There are a few differences. I'm going to focus on the third difference. The first two didn't, in this case, matter to us. It allows infinite chaining of attributes. That sounds pretty magical. What's that about? Well, luckily, there's a link to an example. So it is a black hole object, an object that you can infinitely chain attributes. You can nest them as deeply as you want. So in this case, we create an OpenFastStruct. We're going to call it person. Person has an address. That address has different parts, right? A pretty common thing to divide up into a few fields. So we just create person, and we call person.address.number equals 4. OK. And it's not going to blow up in our face, right? So if we try this with an OpenStruct, what would happen is person.address, well, that's nil. Nil.number equals 4, that's not a thing I can do. So no method error. But in the case of an OpenFastStruct, person.address is going to return a new OpenFastStruct that we're now holding on to as person.address. And then when we call .number equals 4, it'll just assign that as a value inside of that OpenFastStruct. The problem is that this broke things for us. So again, we create a new OpenStruct. We call a non-existent property. It's nil. For OpenFastStruct, it's a new OpenFastStruct. What happens if we put that into an if statement? Well, we had OpenStructs where basically the API was a little bit inconsistent. Sometimes it would have a key, but if the value was going to be nil, it would just leave out the key. So in this case, let's say foo was a non-existent key. That's nil. Nil is falsy in Ruby. Great. If it's an OpenFastStruct, that's going to be truthy. And so our conditionals got flipped, and that made a few tests fail, and it would be a very bad thing if we ever did that in production. So yeah. Basically, what I want to say is just like a drop-in replacement should be a drop-in replacement. The goal here, as far as I can tell, was to make a faster OpenStruct. It was a little bit confusing to me why the author chose to do something different with it. I'm sure there was some business reason. There was he was using it for a certain application and made sense there. But this is something that basically broke our app. It was something that I would assume prevented adoption in a lot of organizations who really could have benefited from it because there was a choice to change the behavior. It was not the same thing faster, it was just a different thing. Okay, so I was thinking about what am I going to do? We have this solution. I could monkey patch it to take out the weird behavior, but is this even the best way to do things? Maybe we can even do better. And I thought about it, and I thought about it, and I thought about it, and I came up with a solution which I call persistent OpenStruct. Okay, so this is our second solution. I'm going to talk about it from the outside in. We'll start with the API, and we'll see how it's implemented. Okay, so you should never use persistent OpenStruct directly. Instead, you generally inherit from it. And then you can define whatever methods you want, like any normal class. But when you create a new instance, in this case, we're going to call it a dog, is a new animal with various, with a type and a sound. You can tell I originally wrote these slides for an American audience because it says woof and not hav-hav. I know my daughters would be very ashamed of me for putting that on the slide, but what can I do? So we have the speak method, which relies on the type and sound properties, right? It's able to access them as though they were normal methods, right? Normal properties for an OpenStruct. And dot notation, bracket notation, everything's exactly the same. However, if you look at the instance methods that are defined on animal, if you pass in false, that means just the ones for animal, not anything higher up in the inheritance chain, right? It's not a very intuitive API, unfortunately. But anyway, you look at the instance methods defined on animal, you'll see type equals and type, and sound equals sound, ears equals ears, etc. So we have all of these getters and setters defined as regular methods on the animal class for every instance. Well, how do we do this? Turns out all I needed to change was 2 lines of code. I took the code directly from OpenStruct and just changed 2 lines. Just to really clarify what I changed, I underlined it. So you can see that instead of defining a singleton method on that individual OpenStruct, instead we just say, OK, well, this is a thing that we need. We're probably going to need it for all the other instances of the same class. So we're just going to call back to the class, and the class will define a new method, right? So it's this is going to be, let's say, like an ears method and an ears equals method, doing the same thing again all the time, assigning to and taking out of an internal table, but it's just using the class, right? And so for every future instance of that class, it'll have all those getters and setters. This is actually, not only is it faster than OpenFastStruct, but it's about 5 times faster than the original OpenStruct, which is pretty good. And yeah, this is a pretty terrible hack, honestly. It's pretty dangerous. If you ever exposed it to user data, you would have serious security implications. So if users are, let's say you use it to take in input users are putting into a form, well, they can start putting in different keys, and you're going to be defining methods, and eventually you run out of memory and your whole server crashes. So don't ever do that. This is really only intended to be used for consuming a trusted API where it's going to be the same set of keys every time. And again, despite the terrible hackiness, it made our app 10% faster. So again, it's 5 times faster than a regular OpenStruct. It made our app 10 times faster. Those are both things that we measured, because if you don't measure, you don't actually know if it's helping anything. Which is why I'm just going to take a moment to encourage you, benchmark your library if you write a library. If you're writing an application, which is probably all of you, then benchmark it. I realize I shouldn't say all of us, because some of us write SDKs. OK. Sorry. But benchmark your app if you write an app. Just like any time that performance is relevant, if you don't have a benchmark, you don't know if you're making things better. I've done a good amount of performance work in my life, and I'm still probably wrong more often than I'm right. You don't know until you benchmark, both in terms of just the thing itself and how it interacts with the rest of your system. Now, benchmarking, there's a lot written about it. It can be a little bit difficult, I understand. So I want to give you just like the easiest, simplest, no-brainer way to benchmark, which is to use the IPS gem. Benchmark IPS, sorry. So this is a brilliant gem which takes a lot of the guesswork out of benchmarking. There's a whole science around it. This basically just makes it really, really simple. So you require the gem, you call benchmark.ips, you get this block with an X object. I forget what that's an instance of, but basically you create whatever are your test cases, you give each one a descriptive name, and at the bottom you call x.compare. And it'll give you beautiful output like this. So it'll actually do some warming up at the beginning, making sure there's no initial conditions which are going to change how things work from a performance perspective. This is basically to get around things that will amortize over the lifetime of your application. It'll then run for 5 seconds, however many times it can. And then here we can see that the new code that we thought was, in this case, let's say we thought the new code was making our app faster. In fact, it made it slower. This is a thing that you'll find all the time doing performance work. So please make sure that you benchmark. And you know how, so no excuses. But back to persistent OpenStruct. So it's good when you're repeatedly creating data objects with the same shape. There's no reason to use this for a configuration object where you only have one. There's no reason to use this for a test double. And it would be absolutely dangerous to use this if they frequently have different shapes. So really, really, really about the use case. But in the use case that we had, it was really, really helpful. All right, round 3, OpenStruct itself. It turns out that there was some optimization to do in the standard library. So back to Eric Michaels-Over, again, now Eric Berlin. He had this tweet, which I thought was pretty cool, that he made initialization of OpenStruct 10 times faster. How did he do it? How many lines of code do you think it took? Do you think it took 10 lines? Do you think it took 20 lines? Do you think it took 80 lines? The correct answer is -1. All he did was say, OK, well, we're creating this, we're defining all these methods, but are we ever going to really use them? I mean, Maybe we're gonna, we have an API response, we're putting that into an OpenStruct. Maybe it comes back with 40 different keys and we care about 3. Why are we bothering to define the methods for the other 37 cases? And so basically the idea is wait until you hit method missing. That is kind of proof that we're going to need to define the methods. And at that point you define it if you're going to, in case you're going to call those methods again. So it was introduced in Ruby 2.3. This is now just part of how Ruby works. And it is a dramatic improvement when you don't access some keys. If you access all the keys, it's actually slower. But that's the nature of performance work. Again, you have to figure out what's the most common use cases and optimize for them. And very often some cases will be slower. All right, we're on to the 4th round, the last one. So persistent OpenStruct was around for a while. It was making our app faster, but I wasn't really thrilled with it. It seemed pretty hacky. And it was sort of like the quickest, dirtiest, simplest thing I could do to just make OpenStruct faster for our use case. And I said, if I was designing it from the ground up, if I wanted to really publish something that I'm proud of, what would it look like? And so I came up with dynamic class. All right, again, starting from the outside in, what does it look like? Well, it's pretty similar to persistent OpenStruct, but you'll notice right up here, it's a class factory. So instead of inheriting from dynamic class, you actually have to do the best practice of creating your own new class. You can't just use dynamic class directly. Whatever you write in the block is executed at the class scope. So it's the same thing as class something and then end, and the stuff that you put in the middle, that's exactly the scope that definition is going to be executed in. It works exactly the same. Everything here is pretty much the same. There's some difference in the inspect output, which you'll see why very shortly. And again, all the instance methods are defined. But what's going on under the hood is totally, totally different. Let's start on the class level. So we have 2 class methods that are defined. One is attributes, which holds on to a set. Now, a set is, in case you're not familiar with it, is this really wonderful standard library tool in Ruby. It's kind of like an array, but it's implemented as a hash under the hood. So you can, in O of one time, you can access anything that's inside of the set to check if it's there or not. Of course, that comes at the cost of, cost and benefit of every element in the set is unique, right? If you can't have 2 of the same thing in the set. So that's the attributes. And then we have this add methods method, which is, this is the equivalent of new OStruct member, right? So we're saying, okay, class exec, get into class mode and execute this as though it's part of the class definition. We just use add a writer and add a reader. Of course, we make sure we're not overwriting anything that's already there. But again, the usual add a writer, add a reader, which means that, of course, we're writing to instance variables and reading from instance variables. There's no internal table, nothing like that. And then we mark the attribute as having been added. So we grab the new key that we're trying to add, and we just add that to the attribute set so that we won't, we remember not to redefine it later. Okay, so we have, let's say, again, our animal, which is a dynamic class. What happens when we create a new animal? So we're going to hit initialize, as we would expect. We have our optional hash, and basically for each key value pair, we're going to send the key equals method. In this case, we would send the baz equals method with an argument of 4. Since this is, let's say, the first animal that we're creating in the lifetime of our application, so we don't have a baz equals method, we're simply going to hit method missing. That is a very scary regular expression, and I honestly forget what it does. But bottom line is, it's checking is it a setter or a getter. So if the last character of a method is an equal sign, clearly this is a setter. And so we basically pull out the part that's not the equal sign, and we use the bracket equals method, right? So self brackets baz equals the first argument, and again that's syntactic sugar for the bracket equals method. If it's not a setter, obviously it's a getter. So we're going to take baz out of our self again with the brackets method. Well, what are these bracket equals and brackets methods? So brackets is very simple. We're just instance variable get. So we're saying what is the @baz instance variable? Ship it out. The bracket equals method is a teeny bit more complicated, but honestly not that much. Convert the key to a symbol, set the instance variable. In this case, it would be @baz to whatever is the value, so 4, and that's in terms of setting. And then we just make sure. By the way, if we hit this, we have to make sure that we might have gotten here through method missing. So let's just make sure that we have the methods for this key. And so we say, do our attributes include the key? Again, because we use a set, this is an O of 1 operation. It's very inexpensive to do. If not, then we just add the methods. So that is how dynamic class works. Again, the main thing that we're doing here is, we have to do a little bit of fancy footwork, but this way we're not using an internal table. Instead, we're just using regular old instance variables, add a reader, add a writer, kind of a traditional class. It's just that the class gets defined over time as your application is running, which is, again, a little bit scary. You got to think about the security implications, but it works and it's fast. In fact, it's faster than persistent OpenStruct, significantly. It's only 3 times slower than a regular class. Again, still slower, but and of course, I make up the benchmarks here. You can look in the repos to see what the benchmarks actually contain and decide if you think they're valid benchmarks or not. But I think this is about right. 3 times slower than a regular class and about 8 times faster than OpenStruct. So nearly a full order of magnitude faster than OpenStruct. I think that's pretty good. It's again good for the same purposes as persistent OpenStruct. When you have these objects that have the same shape that you're creating again and again and again, you don't want to pay the cost of defining methods every time. But again, it's faster because you don't have that extra intermediary of the internal table. And I think it works the way that persistent OpenStruct really should have worked the whole time. Again, persistent OpenStruct was a good solution that I was able to put together very quickly. Dynamic class was sort of the more thought out solution where I was able to squeeze out even a little bit better performance. So, from a business level, I think it was a success. But I also think, it was really nice. It made me happy. Persistent OpenStruct made me happy. Dynamic class, I enjoyed even more creating it. I remember I was actually implementing dynamic class, like sitting in the I forget which office is where where you like register living in a certain place to pay taxes, stuff like that. Like I was just like sitting there in the waiting line, hammering out some code. It was a lot of fun. And even if it never was used in production by anybody, I still think it's worth it. It's worth it to do experiments. Experiments are wonderful. You can have a lot of fun. Sometimes you create something useful, sometimes you don't, but you become a different you by doing experiments. And I think that's worth it in and of itself. So quick roundup. Number 1, back to the story of OpenStruct itself, getting better. We think that the standard library is so great, and it is. A lot of people have worked on it, a lot of very, very smart people, but don't think that just because it's there and so many eyeballs have seen it means that it's perfect. It's not. There are absolutely things that can be better, even in very, very integral parts of the Ruby language. And every time there's a new version of Ruby, tons of things change in the standard library. Usually not external APIs, but a lot of things change. 2 is make sure that the optimizations make sense for your use case, right? Because there are cases where all these optimizations that we talked about are amazing, and there are cases where they would be neutral or even a negative in terms of performance. So you always have to think about what makes sense for your use case. 3, I can't emphasize this enough, you have to benchmark things. If you don't benchmark, you don't know if you're improving things. And that's like really, really dangerous. 4 is, again, experiments are awesome. I had a great time writing all this stuff. I had a great time presenting it to you and in the other places that I presented it. It's always fun. You usually learn something, and sometimes you even create something that can be really valuable. And finally, each one of you has something to offer. We all come in with our own ideas and our own experiences, the things that we've seen that other people haven't, the challenges that we're facing that might make us think of things in new and creative ways. It only takes one person to create a really, really brilliant tool or a small set of people, but the community has so many use cases, and that's why we need a community to adapt it for ourselves. It takes so many people to adapt it for this kind of a size community. So that's what I got. Thank you very much. I really want to thank Lily for putting up with a lot of garbage from me, in the time that it took to schedule the right opportunity to speak and delaying things. And he really did a wonderful job in general putting this together. Thank you so much. And thank all of you for listening.